Last video we talked about resistive pressure, which is the pressure needed to overcome the tube resistance and drive the flow in the tube, let's say from point A to point E. Now the balloon, we said it has a different shape and different surface area, so we're talking about something called stretchability and stiffness. Stretchability and stiffness are opposite to each other. To explain stretchability and stiffness, let's take these two balloons. We have balloon C and balloon D. I'm going to fill both balloons with the same amount of air, let's say 100 cc of air. Now for balloon C, I filled it with 100 cc of air and it went from this size to this size. And it required 10 centimeter H2O of pressure to drive that amount of air in and achieve this size. While balloon D required only 5 centimeter H2O to drive the 100 cc of air in and achieve the same size. So you can tell that balloon D required less pressure to achieve the same size and filled with the same amount of air. You can tell that balloon D is more stretchable and less stiff compared to balloon C. That is what stretchability is. The other name of stretchability that we're going to use in mechanical ventilation is called compliance. Compliance is the same like stretchability, which means how much pressure required to achieve that change in volume. So in balloon D, for example, how much change in the volume we have and how much pressure needed for that. So the compliance or stretchability is equal to the change in volume divided by the pressure gradient, or how much pressure needed to drive that volume in. So that's what's compliance. So compliance equal to change in volume divided by change in pressure. And you can rearrange this equation to become the change in pressure is equal to change in volume divided by compliance. Pressure gradient needed to drive that volume in, here we call it elastic pressure. So in the tube we call it resistive pressure, in the balloon we call it elastic pressure. So to drive the flow through the tube and into the balloon, you need to overcome the resistive pressure and the elastic pressure. So the pressure that applied at the mouth when you blow air in the balloon through a straw need to be equal to the resistive pressure and elastic pressure to overcome that and allow the flow in. Next video will apply this to our